Right now, as you're watching this, your water heater is heating water that nobody is using. It's been doing it all night. It'll do it all day while you're at work. This is called standby heat loss. The tank heats water, the water slowly cools down, the thermostat fires the burner again. Over and over, every hour, every day, 365 days a year. The US Department of Energy puts standby heat loss at 10 to 20% of your annual water heating costs. That's one in every $5 going to heat water that just sits there getting cold again. Natural gas water heaters cover about 60% of US homes. The average household burns roughly 64 therms a year just for hot water, roughly $80 to $120 in fuel at current rates, more if you've got teenagers who treat the shower like a spa. Electric water heaters are worse. Resistance heating is essentially a giant toaster in a bucket of water, and electricity costs more per BTU than gas almost everywhere in this country.
Electric water heating can run $400 to $600 a year for an average family. Then there's replacement cost. Water heaters last 8 to 12 years. Replacement runs $600 to $1,500 depending on whether you're handy or you're calling a plumber on a Saturday morning in January, which is exactly when they always fail. Over 20 years, your water heater costs you anywhere from $3,000 to $10,000 depending on fuel type, climate, and luck. Hold that number, then I'll show you what $19 actually does. Why this works. The physics in plain English. Before we build, you need to understand why this works, because once you get it, the whole thing clicks. 3 facts. 1. The sun produces about 1,000 watts of energy per square meter on a clear day. That's 10 100-watt bulbs blazing full tilt on every single square meter of sunlit ground, constantly. 2. Water is exceptional at storing heat. It has one of the highest specific heat capacities of any common substance. It takes a lot of energy to heat it, which also means once it's hot, it stays hot for a long time. That's why coastal cities are milder than inland cities. The ocean is a massive heat battery. 3. Black surfaces absorb solar radiation better than any other color. A matte black surface in direct summer sun can hit 150 to 200 degrees Fahrenheit. Dark colors absorb across more of the visible and infrared spectrum instead of reflecting it back. Put those 3 facts together. A large black container full of water sitting in the sun is a solar thermal collector. The sun heats the black surface. The surface heats the water. The water holds that heat for hours. Hot water rises, cold water sinks. This natural circulation, called thermosiphon, moves hot water out of the top of the tank and toward your house without any pump or electricity. The IBC Tote holds 275 gallons. On a good sunny day in a warm climate, that water can reach 120 to 160 degrees Fahrenheit. That's not preheating. That's your entire daily hot water supply, ready to go, powered by nothing but a painted box and sunlight. Materials, everything you need and where to get it. Here's everything you need. I'll be specific because getting this right the first time saves you 3 hardware store trips and a lot of cursing. The tank, IBC Tote. IBC stands for Intermediate Bulk Container. These are 275 or 330 gallon square plastic tanks inside a steel cage, used commercially to ship everything from juice concentrate to food grade oils. You can buy used ones for $20 to $60. You want food grade. This is non-negotiable if you're connecting to your home's potable water. Food grade totes are HDPE plastic. Look for the resin code 1 or 2, and the label will show previous contents. Good. Water, juice, food oils, food ingredients. Hard pass. Industrial chemicals, herbicides, pesticides, petroleum products. Even a cleaned chemical tote can leach trace compounds when the plastic heats up. Where to find them? Craigslist and Facebook Marketplace. Search IBC Tote locally. Farmers, car washes, and food manufacturers sell them regularly after one use. I paid $19 at a local dairy. If you're rural and struggling, check agricultural supply websites or search IBC Tote brokers online. The paint. Matte black exterior paint or flat black spray paint. Matte finish only. Glossy black reflects more light and is noticeably less effective. You want solar absorptivity above 0.95, which matte black typically delivers. Best option for plastic. Krylon Fusion Flat Black. Bonds to HDPE without primer. About $8 per can. You'll need 4 to 6 cans for a full tote. Alternatively, use a self-etching primer followed by any flat black exterior paint if brushing or rolling. Better long-term adhesion. Plumbing fittings. Don't cheap out here. These connections carry water up to 160 degrees Fahrenheit and need to hold pressure for years. You'll need 2-inch bulkhead fitting, food grade, hot water rated, $8 to $15. 3/4-inch ball valves, lead-free brass, X3, $10 to $15 each. Temperature and pressure relief valve, T&P, 125 psi, 210 degrees Fahrenheit rated, $12 to $20. Thermostatic mixing valve, 3/4-inch, $40 to $70. 3/4-inch backflow preventer, $10 to $15. CPVC or copper pipe. Quantity depends on your site distance. CPVC cement and primer, or copper solder and flux. Teflon tape and pipe dope. Total plumbing materials, $80 to $150. Structural base. A full 275-gallon IBC tote weighs 2,295 pounds. Your base handles that permanently. Options. Existing concrete slab, ideal, poured concrete pad, or concrete blocks on compacted gravel. If pouring new, a 4x4 foot, 6-inch thick slab on 2 inches of compacted gravel is adequate. Roughly 10 to 12 bags of 80-pound Quikrete. Insulation. Optional but strongly recommended. Insulate all non-sun-facing surfaces, back, top, sides, with 2-inch rigid foam insulation board or Reflectix. Dramatically reduces overnight heat loss. Budget $25 to $50. Total cost breakdown: IBC tote, $19 to $60. Paint, $15 to $30. Plumbing, $80 to $150. Base, $0 to $60. Insulation, $0 to $50. MISC, $10 to $20. Total, $124 to $370. Yes, I said $19. That's what I paid for the tote, the single biggest component. A complete first-time build from scratch runs $150 to $250. I'm being straight with you about that. The $19 is real. The complete system costs more. It still pays back in under a year. Site selection. Where you put this determines everything. Wrong location kills performance. Right location makes this thing work like magic. Face south. In the northern hemisphere, the sun travels across the southern sky. Your black tote needs to face south to catch maximum sunlight across the full day. Open your phone compass. Find south. That is the direction your tank's broad face needs to point. Deviating up to 20 degrees east or west of true south is fine. Beyond 30 degrees, and you start losing meaningful efficiency. Note, your phone shows magnetic south, which can vary from true south by up to 20 degrees depending on your location. Look up your local magnetic declination at NOAA's website. Within 20 degrees of true south is plenty good for this system. Shade is your enemy. Partial shade during your prime window, 10 a.m. to 2 p.m., will crush performance. Walk your proposed site at different times of day. Check for shadows from trees, buildings, fences, and your own house. The sun is lower in winter, so a site that's fully clear in July may be shaded in December. Use the free app suncalc.org to check sun angles by month before you commit. Tilt angle. For best year-round performance, tilt the collector at an angle roughly equal to your latitude. At 35 degrees north, roughly Charlotte, Memphis, or Los Angeles, tilt 35 degrees from horizontal. No ability to tilt? A vertical tank facing south still works well. Optimal tilt adds 5 to 20% more output. Useful, but not required. Foundation and weight, 2,295 pounds. The ground under this cannot be soft or unstable. Best choices: existing concrete or a freshly poured slab. Get it level. Use a bubble level. Shim until it's right before you fill it. A square IBC tote is a sail. In windy areas, brace it. Ratchet straps to a ground anchor, diagonal steel bracing, or positioning against a south-facing wall, which also reflects bonus solar radiation onto the tank, all work well. The full build, step by step. Step 1. Inspect and clean the tote. Before anything, before you paint, before you plumb, fill the tote to about 1/4 capacity with a garden hose and look for leaks. Hairline cracks are invisible until water pressure reveals them. Find out now, not after a full weekend of work. Check the factory bottom valve. Opens and closes smoothly, seals completely. Check the cage for severe structural rust. Surface rust is fine. Treat it with rust converter paint. If the tote smells like anything other than water, fill halfway, agitate, and drain twice. Repeat until neutral. Step 2. Set and level the base. Position the base before the tote is full. You will not be moving it after. Place your concrete blocks or verify your slab is in the correct south-facing orientation. Use a long bubble level in multiple directions, top to bottom, side to side, both diagonals. Shim with rubber or neoprene pads until perfectly level. Set the empty tote in position. Check level again with the tote in place. Step 3. Paint the tank. Wipe all plastic surfaces with isopropyl alcohol to remove oils and dust. Apply Krylon Fusion Flat Black in thin coats. Keep spray cans 8 to 12 inches from the surface. 2 to 3 thin coats beat 1 thick dripping coat. Let each coat tack up 10 to 15 minutes before applying the next. Cover every surface you can reach through the cage. Aim for 90% or better coverage of exposed area. Let final coat cure 48 to 72 hours before filling. Fresh paint off-gases slightly when heated. Full cure first minimizes this. Step 4. Install plumbing fittings on the tank. Your IBC tote has one factory fitting, a 2-inch buttress thread valve at the very bottom. This becomes your cold water inlet. Cold water enters from the bottom because cold water is denser and sinks. This is the thermosiphon principle working for you. Your hot water outlet needs to be at the top of the tank because hot water is less dense and rises naturally. Drilling the hot outlet. Use a step drill bit or 1-inch hole saw. Mark the upper quarter of the tank panel facing your house plumbing. Drill slowly. HDPE cuts cleanly but generates heat. Keep the bit moving and don't force it. Clean the hole edges with a sharp knife or file. Install a 3/4-inch bulkhead fitting from inside the tank. Reach through the top opening. Thread the nut on from outside to compress the gasket. Hand tight plus a half turn with pliers is enough. Do not over tighten. You will crack the HDPE. Leak test before proceeding. Fill to 1/4 capacity through the top. Wait 20 minutes. 0 drips required. If anything seeps, drain, reseal with fresh pipe dope, and recheck. Step 5. Install the T&P valve. Do not skip this. Read this section twice. On hot sunny days, your solar tank will produce water well above 150 degrees Fahrenheit. Without a pressure and temperature relief valve, that heat and pressure has nowhere to go. The T&P valve is a spring-loaded device that opens automatically if water temperature exceeds 210 degrees Fahrenheit or pressure exceeds 125 psi, safely venting discharge downward through a pipe toward the ground. Install the T&P valve in the upper third of the tank. The discharge pipe must point downward, terminate no more than 6 inches from the ground, and have nothing blocking the outlet end. No cap, no valve. Use CPVC or copper for the discharge pipe, not PVC, not garden hose. The discharge can be scalding water or live steam. This is building code in most jurisdictions and genuine safety practice. Install it correctly. Step 6. Install the thermostatic mixing valve. Because your solar tank can produce water significantly hotter than safe delivery temperature, you need a thermostatic mixing valve on the hot water outlet line. This valve blends cold water into the hot stream to deliver consistent, safe temperature. Set it to 120 degrees Fahrenheit. A mixing valve costs $40 to $70 at any home improvement store. It prevents scalding and keeps temperature consistent regardless of how hot the solar tank gets. Install it on the hot outlet line before it connects to your house distribution. Step 7. Connect to your house plumbing. The parallel connection. Recommended. Your solar tank connects in parallel with your existing water heater. Cold supply feeds both. Hot output from the solar tank feeds your home's hot water distribution. Your existing water heater acts as backup, firing only when solar hasn't heated the water sufficiently. You always have hot water regardless of solar conditions. Step by step. 1. Shut off your home's main water supply. Open a low faucet to drain line pressure. 2. Find the cold water main before it splits to your existing water heater. Install a T. This is your solar cold supply takeoff. 3. Run 3/4-inch cold supply line from this T to the IBC Tote's bottom valve. Include a ball valve for isolation. 4. Adapt from the IBC Tote's 2-inch buttress thread to 3/4-inch NPT at the bottom valve. 5. Run 3/4-inch hot line from the Tote's top outlet fitting back to the house. 6. Install your thermostatic mixing valve in this hotline with a cold water T to the mixing valve's cold port. 7. Connect the mixed output to your home's hot water distribution, where your existing water heater's hot outlet joins the system. 8. Install backflow preventer on the cold supply line to prevent hot pressurized water from flowing backward. 9. Install isolation ball valves at every junction so you can shut off the solar system independently without affecting your conventional heater. Pipe material. Use CPVC, rated to 200 degrees Fahrenheit, or copper for all high-temperature lines from the solar tank through the mixing valve. PVC softens above 140 degrees Fahrenheit. Do not use it before the mixing valve. After the mixing valve, PEX is fine. A word on permits. Most U.S. jurisdictions require a permit to connect new appliances to home plumbing. Get it? If there's ever a leak and insurance is involved, unpermitted work complicates everything. The permit also gets you a free safety inspection. Many states also offer solar rebates that require a permitted installation to qualify. Step 8. Fill, test, and commission. Open the cold supply to the solar tank slowly. Leave the top cap slightly open to vent air as water fills. Watch every connection. Have a towel handy. When full, close the top vent. Open isolation valves to connect solar hot output to the house system. Run a hot tap indoors. Check water temperature. Should be at or below 120 degrees Fahrenheit. Adjust mixing valve if needed. Check all connections again after 1 hour of normal use. Over the following 3 days, inspect every fitting each morning. New connections can weep slightly under temperature cycling. Catch them early. Tighten or reseal immediately. On the first sunny day, track tank temperature at 8 a.m., 10 a.m., 2 p.m., and 5 p.m. In good sun, expect 40 to 80 degrees Fahrenheit of rise over a full day. That's your performance baseline. Manually test the T&P valve by lifting the test lever briefly. Hot water discharges from the pipe. Release. Stops immediately. If it won't stop discharging, replace the valve. Test this annually going forward.